What's up, family? I'm back again for another live. Back again. So as you can tell by the title, you see what we're covering today. We're covering the winter solstice from 2023 to 2024, which is going to be extremely different based off what I'm about to show you today. So I appreciate everybody for tuning in yesterday to my when I was covering Halloween. So yeah. Today we're covering the weather side of things. So let's see. You know me, I'm gonna get right into it. Uh, First, I want to say, hope everybody had a blessed, full of abundance day, and I hope everybody's energy is still rising, and everybody's knowledge is growing up and getting higher and higher. Because that's all we here to do anyway is gain knowledge and experience life in a different type of energy. So I hope everybody's doing that first, first and foremost. So basically, what I'm gonna do is I'm gonna talk about the weather that's happening now, but we're gonna start all the way back. I like to start from the beginning and break it down step by step because I like to get my understanding of how I want things to operate. So hold on, let me first do this. Boom. Okay. I'm gonna do that first. All right. So that's taken care of. Let me move my computer over a little bit. All right. So we're gonna get right into it. Let's see. I want to start with this tab right here. Okay. Let me go back. All right, got it. So we're gonna start from the beginning, then we're gonna work our way down. I want to basically go over a few things before I play the video at the end, so we all can have the same understanding because I'm learning this the same way that y'all learning this. We all learning together. So the winter solstice. This is called the northern winter solstice, and it is when we have the least amount of daylight of any time of the year. During this time, the sun appears lowest in the sky with the least angle to Earth, and we receive less sunlight and warmth. This is also when the days are shorter and the nights are longer. Okay. I basically wanted to cover that just so we can understand the solstice. So let me go up, kind of see a picture. I see some pictures over here. All right. Boom. Okay, so the solstice, that's basically how they're saying it is. So we receive less sunlight, which is basically the time of the year where we have the less radiation hitting the planet to keep us at this good tropical type of weather. The days are shorter because the light isn't hitting as strong as it usually is, but for some reason the sun is closer. So since it's closer, it's lower in the sky apparently during this time. And let me go back. So that's the winter solstice. It's basically the time of the year where we receive less sunlight than normal. So this winter solstice is to start December 21st of this year. All right. So we have an understanding of what the winter solstice is. So it's basically starting from the cosmos out in outer space is basically the way the planet is moving and shifting around our sunlight, which is our main energy of life. It has a back effect on Earth for our weather. So we got that together. So now we understand that. I want to go on to this next one. I'm gonna kind of just breeze through it because I just want to breeze through it. It's not going to be a long video today. It's just going to be a nice quick one. So I want to start with the Nino and the La Nina. So for the past 3 years, they said we was in the La Nina phase. And now this year, we're in the El Nino phase with a twist to it. So let me just read what it is. Okay. So during normal conditions in the Pacific Ocean, trade winds blow west along with the equator, taking warm water from South America towards Asia. To replace the warm water, cold water rises from the depths, a process called upwelling. El Nino and La Nina are two opposing climate patterns that break these normal conditions. Scientists call these phenomena the El Nino Southern Oscillation Cycle. El Nino and La Nina can both have global impacts on weather, from wildfires to ecosystems and economies. So, I'll finish it. So, episodes of El Nino and La Nina typically last 9 to 12 months, a year, but can sometimes last for years. Okay, so like the past 3 years, we had the Nina. El Nino and La Nina events occur every 2 to 7 years on average, but they don't occur on a regular schedule. Generally, El Nino occurs more frequently than La Nina. All right, so take that. Then we're going to send that El Nino. During El Nino, trade winds weaken. Warm water is pushed back east towards the west coast of the ocean. I'll show this diagram while I talk. El Nino means little boy in Spanish. Of course, it means the boy. We got it. South American fishermen first noticed periods of unusually warm water in the Pacific Oceans in 1600s. The full name they used was El Nino de Navidad because El Nino typically peaks around December. El Nino can affect our weather significantly. The warmer waters cause the Pacific jet stream to move south of its neutral position. With this shift, areas in the northern U.S. and Canada are drier and warmer than usual. But in the U.S. Gulf Coast and Southeast, these periods are wetter than usual and have increased flooding. So as you can see in the diagram, it's showing the effects of El Nino. So it's showing down here, it's more storms like floods and hurricanes, etc., all the way down here, and it's more drier air at the top. So I'm gonna go back. It says El Nino and La Nina, right? First off, El Nino, they're talking about wildfires in the ecosystem. So right there, you see the increase of wildfires we've been having lately, which shows that we're in El Nino. That's why we've been having experiences of wildfires and certain colors in the sky, etc., going around the planet more frequently than we usually have. Second, El Nino is pushing warm air towards the east, but from the west coast. So it's like basically, let me show you on the map. So basically, it's coming from where this says extended Pacific jet stream and it's pushing towards this way, going up towards where it says dry on the purple on the map. El Nino is, I guess you could say, masculine energy, and then La Nina is feminine energy. So, with feminine energy, it creates and shows evolution and nurses and brings things to peace and harmony. And masculine energy is the enforcer. It shows change and it shows how things are supposed to be, and it resets everybody back into their positions, right? So Nino, like they said, the masculine energy is coming on the planet strong, but it's coming under the law of feminine energy. So El Nino is coming to basically put that fight back into the planet. Basically, it's basically restoring balance to the planet. When El Nino comes, it's more intense weather. You see, it says increased flooding. It's more warmer than usual. Okay. And on top of that, it's more storms happening. So around December or whatever you want to call around the winter solstice, the weather is more You have storms, you have snow, you have rainfall, etc., right? Nino intensifies it. So it's like basically pushing more of a cleansing type of personality onto the planet more so than the La Nina. Okay. So El Nino also has a strong effect on marine life of the Pacific Ocean, of the Pacific coast. During normal conditions, upwelling brings water from the depths to the surface. This water is cold and nutrient rich. El Nino upwelling weakens or stops altogether. Without the nutrients from the deep, there are fewer phytoplankton off the coast. This affects fish that eat phytoplankton and, in turn, affects everything that eats fish. The warmer waters can also bring tropical species like yellowtail and albacore tuna into areas that are normally too cold. Which you've been noticing, a lot of scientists lately have been saying, oh, we've been finding creatures in the ocean that we haven't seen for the longest and longest of time. They're bringing these, they're saying like, oh yeah, we're finding ancient creatures that came out of water. Well, it's because the water is heating up. So these creatures have more room to move around in. On top of when the water heats up, a lot of small, like you said, phytoplankton and coral reefs, etc., they can't survive in that temperature. Okay. In a small El Nino, because El Nino has different levels. In a small El Nino, they could probably get away with it. But once it gets to medium to high, they can't withstand that temperature. So a lot of marine life dies off. Okay. La Nina. La Nina is, we'll skip all this, what it's called. It has the opposite effect of El Nino. During La Nina, events trade winds are even stronger than usual, pushing more warm water towards Asia. Off the west coast of the Americas, upwelling increases, bringing cold, nutrient-rich water to the surface. These cold waters in the Pacific push the jet stream northward. This tends to lead to drought in the southern U.S. and heavy rains and flooding in the Pacific Northwest and Canada. During the La Nina year, winter temperatures are warmer than normal in the south and cooler than normal in the north. Okay. La Nina can also lead to more severe hurricane seasons. So basically, how, you know, how they say up north is always cold up north and down south it's always warmer. And like people from like Georgia, they'll be like, yeah, man, it's not, our winters isn't like y'all winters. Like they'll come up to the East Coast and they'll be freezing their tail off and it'd be like 70 degrees. And I'm like, what y'all freezing for? And I'm like, man, our temperatures don't get like that. Well, now it's starting to switch since El Nino is coming to effect. All that is reversed. All of this is reversed now. So you have warmer, drier temperatures up north, and you have colder, more wet temperatures down south now since this is switching. You see how the arrow is going upwards this way, and then you go on the map of Nino, and it's more lower. You see, and the polar jet stream is more in Canada than it is in the US. So it's showing how the temperatures is much warmer in El Nino than in La Nina. Okay. I just wanted to show you guys that so you can know the two differences between those two. Now I want to get into, like I said, I'm just going through it, just give you a little rough draft. You could put more studying into it if you would like. So now we're going into the polar vortex. Okay, we just discussed the Nina Nino. So basically you still see it like along this globe. You see these arrows. It's basically still showing you the effects, but it's just showing the polar vortex. So you see how in the stable polar vortex, this is during the La Nina. You see how the cold air is more contained in the northern regions. It's not out of control. It's fluctuating at a right speed. The polar jet stream is keeping the vortex contained. When it's disrupted, which is basically Nino, you see how the lines are lower like they were showing in Nino's map, and then the cooler temperatures are higher like they were showing Nina. Well, in Nino, you see it's more disrupted. That means the shift is more out of control. The cold air is escaping more so from the northern regions and able to travel around, and the warmer air that's pushing up upwards is weakened from being able to keep it contained because it's just flowing all around the place. Okay. So it's basically like keeping air encaged, right? You keep air trapped in a container, and then imagine you put a crack into the container and some of the air starts seeping out. Now that airtight seal isn't as good. So if you keep something in it, it's not as fresh. It's not staying in there contained. That's basically how the polar vortex works, which is basically like North and South Pole. That's how it works. So I'm going to read about it. It's kind of small, so I'll just read it. The polar vortex is far above and typically does not interact with the polar jet stream. You see that? You see how the polar jet stream is lower and the polar vortex stays in its contained space. Okay, so it does not interact with the polar jet stream. The flow of winds in the troposphere 5 to 9 miles above the surface. But when the polar vortex is especially strong and stable, the jet stream stays farther north and has fewer kinks. This keeps cold air contained over the Arctic and the mid latitudes warmer than usual. Every other year or so, the Arctic polar vortex dramatically weakens. The vortex can be pushed off the pole or split into two. You see that? It can split into two. The vortex can be off the pole or split into two. Sometimes the polar jet stream mirrors the stratosphere upheaval and becomes weaker or wavy. At the surface, cold air is pushed southwards to the mid latitudes and warm air is drawn up into the Arctic. Okay, I was saying this. The reason I'm showing you this is because I'm going to show you how this is showing how the planet is going into the polar shift, where the north is going to south and south is going to north. This is basically how they're explaining it without explaining it. You see, the cold air at the north is losing pressure, so it's escaping, it's traveling downwards to the planet, is able to move around, and the warm air is moving upwards. So it's basically like it's switching positions. And you see how this was centered, right? When it's contained, it's centered, it's staying in one area. When it's not centered and stable, it can move anywhere it wants. It just travels. The cold rush travels. So you'll have cold fronts in regions that it's not supposed to because it's moving around. I know a lot of you heard about when they were saying the the North Pole was moving around from Russia and moving in Canada and moving all around, and it was like it wasn't staying how it was in one spot. This is basically what they're showing, and this is basically what they was talking about. It's traveling. This cold air is traveling, so you never know where it might freeze over, and you never know where it might warm up at. Okay, so we're going to the U.S. How can the polar vortex cause extremely cold temperatures in the U.S.? Sometimes this low pressure system full of Arctic air can weaken and travel from its usual position, like I was saying. As this system weakens, some of the cold Arctic air can break off and migrate south, bringing plenty of cold air with it. Areas as far south as Florida may experience Arctic weather as a result. Like you seen in Texas, they was freezing over, and in Florida too. Like I was going to school down Florida, and the first year I went there, they experienced snow, and they had to cancel school, and it was like no more than a half inch of snow. It was like something that up north we'd just laugh at. And they had this snow on the ground. They was like canceling, and they had a whole big thing. They said because we don't have snow equipment, like we don't prepare for it. That was like the start, and that was back in like 14 or 15 or such, something like that. So when the low pressure system is strong and healthy, it keeps the jet stream traveling around the earth in the circular path. The jet stream is band of reliably strong wind that plays a key role in keeping colder air north and warmer air south. But when the vortex weakens, part of the weakened low pressure system can break off. This breaking off process is what can cause colder temperatures in the US. Without that strong low pressure system, the jet stream does not have enough force to maintain its usual path. It becomes wavy and rambling. When high pressure system gets in the way, a collection of cold air pushes south along with the rest of the polar vortex. As you see in this map, it's just able to move around more, so it gets more freedom. You know what I mean? And down here is the hot areas where the air is normally hot. Equator and south of the equator is typically just a hot environment, and it's traveling upwards. When the cold air travels down, it's traveling upwards. So it's kind of like a swap, like you would say a polar shift. Okay. So that's how the polar vortex works. Had to get into that, had to knock that out the way. And I get to say that to show this. So we learned about the Nino, the Nina, we learned about the polar vortex, we learned about winter solstice. So now we're talking about the oceans. One of the most worrying trends has been what scientists have called an unprecedented planet-wide ocean heat wave. Planet-wide, not just Atlantic or Pacific. The whole planet's oceans have been hotter than normal. June saw the highest ever average global ocean surface temperatures, with the local records being set from Ireland to Antarctica, from the top to the bottom. In Florida, waters reached 38 degrees Celsius. Okay, so in Florida during this year, around their coast, they noticed that the ocean was reaching hot tub temperatures. It was as hot as a hot tub in the ocean, like boiling. This was taking out their reefs, like all their coral reefs was getting taken out. A lot of life that lived in the reefs, of course, they had to leave too. Like we were seeing in the Nino, a lot of marine life had to leave because the temperatures wasn't good for them. They couldn't survive in it, and it was killing all their food that they ate on. So all the Atlantic to Pacific, all of it is hotter than normal. And now we're in Nino. So, Nino starts from the Pacific, as I showed in the map. Let me go over to it again, just to bring you back. Nino starts in the Pacific region. Over here is the Atlantic region. So now the Atlantic region is hot as well. Usually the Pacific is hot and the Atlantic isn't as hot to where it can allow the heat to travel towards this direction and disperse evenly or get itself back in track. Now it's hot over here too. So it's like basically sandwiching heat onto the land, onto the whole Americas, well, the whole world really, but we're just talking about America right now. It's sandwiching the whole Americas with heat, intense heat, which is throwing it off and tremendously. So now we're into the winter solstice part of the region. This heat is coming to contact and doing this, which increases storms, which increases flooding, which increases snow, like exponentially. It's going off the charts. And scientists have never seen this happen ever in the history of weather, ever in life. They never seen the Atlantic hot and the Pacific being in El Nino hot as well. And they're coming into the winter solstice, and they're both at high temperatures. They never seen this ever. It's never marked. They don't know what's really going to happen. They just all guessing. And we'll see that in the video I play at the end. But these two are coming in contact with each other, and it's causing havoc on the land. It's causing havoc in the ocean. It's causing havoc everywhere, worldwide. Nobody's escaping. That's why it's harsh weather across the globe right now. It's because the global warming, or whatever you want to call it, the climate change, is heating up from the sun's intensity. The sun is sending rays down to this planet, which is changing the way that the planet usually operates. Now it's like everything is just stronger, more intense. It's just way more intense. Okay. So now I want to get to the poles changing. So it says, what would happen if the Earth's poles flipped over? As we're seeing, the poles are flipping over as we speak. It's in the process of doing it. Fortunately, short of being hit by some vast celestial body, the Earth can't flip over, as the moon's gravity field keeps our planet on a fairly even keel, quote unquote. But the magnetic poles can and do undergo complete reversals, most recently around 780,000 years ago. And it's like, how do y'all know that for real? But we'll play along. 780,000 years ago, the weakening of the magnetic field as it undergoes a complete flip would make the Earth more vulnerable to the effects of solar radiation. Okay. So when the poles flip like that, it's taking away the protection that's around the planet to allow more solar radiation to come in. And you got to think about it. More solar radiation means more heating heating of the planet. We're already getting hit by intense heat waves and the ocean heating up, and which is causing this polar shift to happen. Everything is coming from the sun signal already to the planet, causing this polar shift. So now that this polar shift is hitting the planet, it's making the poles want to change their positioning around to where now the Earth is more vulnerable to outside radiation from the sun hitting the planet even more intense. And it says, which has the power to disrupt power lines and telecommunications, which is basically electricity, which is basically how the world operates right now. Everything runs off electricity. If you think about it, even outer space runs off electricity. We have electromagnetic grids. We have an electric, uh, we have a magnetic pull, which they call the orbit, which is basically electricity magnetically connecting the planets around. Everything's moving off electricity. So when they disrupt the electricity, they're basically shutting off artificial electricity and creating their new wave of electricity on the planet. When this happens, the solar radiation is so intense that people aren't going to be able to survive this. Okay. People aren't going to be able to survive it. And on top of that, they ain't even going to be able to survive without no electricity anyway, at least majority of the planet. People can't live on their own. And they basically keep it short and sweet in this article. It's like they don't want to get too deep into it. Let me see. Let me go back. All right. No, that's not it. So this is a question that says, what if the Earth's magnetic field disappeared? So basically we're seeing the solar radiation is hitting the planet because it's more vulnerable because the magnetic field is dissipating, it's getting weakened. Okay. If the Earth's magnetic field disappeared, the entire human race and all of life, in fact, would be in serious danger. Cosmic rays would bombard our bodies and could even damage our DNA, increasing worldwide risk of cancer and other illnesses. Now, I'm not going to be, all right, I'm going to keep it 100. These things can happen, but not to our people. You know what I mean? We take in sunlight. Our body feeds off sunlight. Like the what you would call melanin in our skin needs sunlight in order to exist. The darker you are, the more you need to feed your body. You know what I mean? So them saying that cosmic radiation is going to hurt and cause cancer and illnesses, if you think about it, Black people didn't get cancer and illnesses like that from the sun or radiation until they adopted the eukaryotics way of lifestyle. That's what caused us to get in a position to where now all of a sudden everybody's catching cancer. You think about it, back in the days when our great grandparents used to smoke cigarettes and do things and drink, their bodies was fresh before being toxified with this stuff. So they was able to fight it off more. They wasn't catching cancer back then. It's starting to intensify now because during generations we're weakening our DNA more and more. The more that we take in this, the more that we adopt this lifestyle, we're just basically taking ourselves out with them. It's like they're down at level 2, we're up at level 30, and we take their lifestyle and we're just coming down slowly but surely down to level 2. It's going to take a while before we get to level 2, but we're coming down. But the fact that we energize the planet, when we take ourselves down as a whole, we're taking down the planet as well. You got to think everything rotates and needs each other. So just like we need the earth needs us. We're put down on here to experience life, and we're put down here to take care of the planet that which we created with our thoughts, without energy, without um want for experience. We put this together to experience life. And now, since we're not taking care of the place where we're coming to experience life. Now the life on the planet is dying down while we die down. So it's like you take yourself down out of the natural way you was programmed for this. Like I said yesterday, they have a way, they had a reason they came down here. We have a reason we came down here. We came down here, we're supposed to be taking care of the planet. We're supposed to be fixing nature, growing crops, taking care of the animals, taking care of each other, growing up positive energy and helping nature just blossom to the fullest of its potential. Now that it's not doing that, that's what the planet runs off of. We're taking nature from it, so the planet is weakening. So when the planet weakens and it gets sick, it's alive. It's a living being. When the planet gets sick, it does just like you would do if you get sick. It fixes itself. It heals itself. So this polar shift is like basically like a backup plan that the Earth had already in set, to where when it gets broken down to a certain level, it just shifts around and it's able to fix and cleanse itself. And once it cleanses itself, it restarts life over again, basically, to start with new healthy cells. It's like you flush your system out and you start off fresh. So that's just what this is basically doing. So the magnetic field disappearing, well, dissipating from this polar shift is what's causing all this cancer rising. It's causing people's brain to go crazy. They can't think straight. They're thinking like animals out here. It's what's causing natural disasters. It's what's causing weather to not even be the same no more. Like when it gets hot, when it usually gets hot, it's like 10 times hotter. And when it gets cold, when it's supposed to get cold, it's not even getting cold at that right time. You got to think, like last week, I'm in DC. I don't know where you guys at, but I'm in DC. So last week it was 80 degrees outside. This week, 40. I'm willing to bet you that in the next week or two, it's going to get back hot again, and then it's going to get back cold again in the following days. It's like you can't, when you see that El Nino, let me go back to it one more time, and then I'm going to play this video. But when you see this happening, this energy, the cold front, actually, let me go to the vortex to explain it. This is unstable. Okay. This cold air is unstable. So you don't know where it's going with it. Okay. You don't know where the cold air is going to escape and run through and the path is chosen. You only know, they can only predict the weather when the vortex is stable. They can't predict the weather when it's disrupted. It's like a ticking time bomb. You don't know what's going to happen. You don't know if it's going to be extra hot, if it's going to be extra cold. You don't know nothing. Okay. And on top of that, this weather from this, when it's hot like this, and it's hot in the Pacific and Atlantic Ocean, is creating more moisture in the air. Okay. And all weather feeds off this moisture that's in the air. So that's why the hurricanes is intensified. Flooding is intensified. These snowstorms will be intensified. Everything will be intensified to the max. Okay. Nothing is going to be just regular. Okay. You say the same in Missouri. Yeah. Everything is not going to be the regular. It's not going to be regular. It's going to be outrageous weather, whether you get a rainstorm, whether you get a snowstorm, whether you get anything, flooding, tsunamis, whatever you get, we experience tornadoes, whatever you experience, it'll be intensified. Okay. And there's no telling where it's going to be at, because the regions is all over the place. This vortex is moving around. Okay. So with that being said, I want to get into this video. Okay. I told you guys, I'm going to just breeze through. I want to show you guys this real quick. So I'm going to show you this video, and I basically want you to hear what the guy is saying, so you can understand. Now that we have an understanding of everything, I want you to hear what this guy is saying, basically. So I'm going to play it.
Be really interesting because right now, all around the globe, there are major weather pattern changes going on, and these changes are going to directly affect our winter here in the US. Arctic blasts, blizzards, and even severe weather are all on the table. But the interesting part is where these things are going to happen. In this video, I'm going to tell you all about that and what you can expect in your own backyard. So you've probably heard about it by now, but El Nino is ramping up down here in the Pacific Ocean. This pretty much just means that the waters are getting much warmer than usual, and since this is such a big body of water, its temperature fluctuations have major impacts on the weather worldwide. For the past 3 winters, we've been in a La Nina, which is when those Pacific waters are actually colder than usual. So as we head into our first El Nino in quite a while, we're expecting some big changes. During a typical El Nino winter, we usually see an extended Pacific jet stream, and this brings a lot of storms into the south. We also tend to see the polar jet stream cut across the Great Lakes, allowing for much warmer than average air to build up underneath it in western Canada and through the northern US. At the same time, things get a lot wetter and somewhat colder down here in the south thanks to all the storminess. And in between all those areas, we usually end up a bit drier than normal, but things fluctuate a lot here. But here's the thing, what I just showed you was a typical El Nino, and what we're about to experience is anything but a typical El Nino. You see, here's where we are right now with sea surface temperatures in the Pacific, and here are all the specific places that we monitor when determining the intensity of an El Nino. You can see very clearly that we are warmer than average across the board, and you can also see here the long history of these waters being colder than average, but more recently things have actually kind of flatlined. And if the warming stopped here, we'd be looking at only a weak to moderate El Nino for this winter, which would make a big difference in the overall USA forecast. But is the warming going to stop here? Well, let's take a look at some forecast models. Here's the latest projection from the CFS model. As you can see, just a few weeks from now, we do expect these waters to start warming significantly once again. And by around October, we're probably going to be in at least a moderate to strong El Nino. So what exactly is the impact here in the US when there's a strong El Nino versus a weak El Nino in the winter? Well, as far as temperatures go, with a weak El Nino, we would expect to see much colder than average temperatures for a lot of the East Coast due to that polar jet making its way farther south. But with a stronger El Nino, things are completely flipped. We get colder in the west and somewhat warmer in the east. But even dialing it down this much does not tell the whole story. Sure, it looks like we're going to have a moderate to strong El Nino, and we're going to have a lot of historical data to back up what that actually means for us, but there is no historical data whatsoever for this next big part of the equation that we have to figure out, right?
No historical data at all. Okay, make sure y'all call that. No historical data. They don't know what's going to happen.
Now, the Atlantic Ocean is hotter than it's ever been before. And not only will that have implications on this hurricane season, but these warm waters have the ability to feed all storms, even snowstorms, especially east of the Mississippi River. Most of our bigger storms rely on warm, moist air from either the Gulf of Mexico or the Atlantic to survive. And the warmer and more moist they are, the bigger the storms can potentially be. If we get into a situation this winter where we have abundant cold air and the sea surface temperatures are still this high, we're going to have a very active stretch of big-time snowstorms. But once again, we haven't really ever seen an El Nino winter where the Atlantic was so warm, so we have nothing to compare this against. Now, we're still quite a ways away from winter, and there's only so much you can predict at this point. But I do have a preliminary and very early winter outlook for you. First of all, in general, I think temperatures are going to follow a pattern consistent with the strong El Ninos of the past. It's going to be much warmer than usual in Western Canada, and a lot of that warmth will dip down into the central US as well. In the south, due to the amplified storm track, things are more than likely going to be quite a bit colder than usual. And despite the record warm sea surface temperatures in the Atlantic, I think a lot of those southern storms are going to travel parallel to the East Coast, and that's going to bring down much colder air on a more regular basis to the eastern states. And everyone else in between can pretty much expect mostly average or typical seasonal temperature changes and swings this winter. Now, that's a pretty useful forecast for sure, but I have an even more bold prediction for you right now. Based on everything we've learned today, I think I have an idea as to where our next Big Daddy snowstorm is going to be. What in the world is a Big Daddy snowstorm, you ask? Well, just about every year, somewhere in the US, there's a snowstorm that's quite memorable for the people it impacts. You've probably heard people talk about the blizzard of this year or that year, or you've heard somebody say, I remember back in the old days during the great snowstorm of 1980 whatever. It's those kinds of storms that I refer to as Big Daddy snowstorms. I think there's a good chance we're going to get one this year, and I've got a map showing you where it's most likely to happen. First off, here's the general 2% likelihood area. It's big because the probability is small. Now, here's the fun stuff. The dark blue represents where I think we have a 5% chance of seeing a Big Daddy snowstorm this winter. The pink is going to represent a 10% chance, and the red is actually going to be a 15% chance. I think that at some point this winter, a large area of cold air is going to be in place as one of those El Nino enhanced southern storms starts tracking north. When that happens, someone is going to get a heaping helping of snow. Now, of course, this is a wildly early prediction to make, and it's mostly just for fun, but go ahead and hold me accountable. If you want to come back to this video in March or April of 2024 and let me know how I did in the comments, I would love that. The reason I have any shred of confidence here is because El Nino winters and Big Daddy snowstorms are no strangers. A lot of you probably remember the January blizzard of 2016, which dumped up to 3 feet of snow across the mid-Atlantic and caused over $500 million in damage. That storm occurred during the 2014 to 2016 El Nino event, which is regarded as one of the strongest El Ninos in recorded history. Another strong El Nino occurred in 1997 and 1998, and there was a ton of big winter storms during this time period, including the January 1998 North American ice storm, which actually left 4 million people without power and caused $7 billion in damage. And the list really goes on and on. And it's also important to note that most of these El Nino winters were also quite active in terms of severe weather. Due to that increased southern storm track and large temperature swings, severe weather outbreaks are unfortunately something that we're certainly going to be dealing with this winter. So whether you're dealing with a Big Daddy snowstorm or big nasty thunderstorms this winter, something I think you're going to need is a good radar app. Just look at me. My life revolves around the weather. It's very obviously a big part of my life, and you know how I choose to monitor the weather? On my phone most of the time.
So right there, family, I'm just showing y'all this weather he's showing that's happening. The studies that they did have of El Nino was when the Atlantic was still cool. Now that it's not cool, they don't know what's going to happen. It was already intense when the Atlantic was still cold. Okay, all this energy on this planet, right? They're saying basically on both sides of the board is the same type of temperature. It's hot air coming up to the northern regions, cold air coming down to the southern regions. This is making everything intense. Any type of weather you get will be intense. And they're showing this to tell you basically like, yeah, we up in the clouds with, I guess, like you can guess better than I guess. Like we don't know. We know last time when the El Nino hit, it was bad, devastating. 4 million people without electricity. That's a lot of people. 4 million people. That's a lot of people without electricity. Imagine now, it's probably going to be like 8 to 20 million people without electricity. So I'm showing you guys this to show you to be more prepared, okay? You guys got to get water, food, and everything just stacked up, okay? You can't just be out here just thinking you're just going to sit outside, get some sunlight, and eat healthy, and you're just going to be good and you're going to make it through. No, you have to do that and more. You have to put work in. We've been asleep for too long. We got to put this work in. We got to work harder to survive through so our people can make it through to the next chapter of life. It's not just sitting there just relaxing. It's real hard body. Yeah, chosen one. Facts. You got to get prepared for this. You got to have everything ready for you. Like in my closet, I got endless supplies of water. I got a whole bunch of water. I got survival kits. Okay. I got food that can last on the shelf for 10 years. I got emergency water in packets. You know what I mean? I got the straws to where you could drink from anywhere. I'm sitting there looking at how to build. You know, the guys on YouTube that be building houses and stoves and everything out of nature. They use rocks in the woods and they just build for and they live in the woods forever. I'm looking at all this because this could be your life real soon. And the country is not gonna get you prepared for this at all. They just gonna they gonna be saving themselves. They just gonna look at you like, damn, yeah, he got fucked over, man. You know what I mean? It's like if you see a person pulled over by the police and you see how everybody always look and be like, dang, they got them. That's how your country's gonna look at you when this hits. When these polar shifts happen in the weather, and it's gonna be intense weather. It's not just gonna be the regular weather they're used to, it's gonna be intense weather. When this hits, nobody's gonna come to save you. No government's gonna come, no come, oh, you could come to this camp and stay here and get your food and supplies. Yeah, you can come there, but you gotta make it. Ain't no helicopters gonna come fly and get you. You seen how Trump did them down wherever he went to. Remember, he was throwing the paper towels in the crowd. He didn't care about them people. He was playing basketball. Woo! He was having fun. That's how your country looks at you. They just letting you know, and they give you certain signs that this could happen, but they're not telling you like, yeah, it's for a fact happening. You have a couple people telling you for a fact it's happening, but most people aren't telling you for a fact it's happening. They're saying, oh, it's a possibility. It's a possibility of this. Well, the possibility time is over with. This is what's happening. So I just showed you guys that just so you can get a quick glimpse at it, understand where I'm coming from. I hope that you guys have a prosperous life. You know what I mean? Keep your energy high, make it through whatever you're going through, stay focused on the real game plan. You know, coming here to do what you was meant to do when you came here. Getting back to that, getting back to your old ways. Just don't be stuck in your ways that you learn through childhood and being in the streets and whatever you came from. Learn your natural way, what you was meant to be here for. That's what you need to learn. Okay. So appreciate you guys for tuning in. Like, comment, star strive, and I'll be back again with another one, man. I just had to start it off right. You know what I mean? Peace and abundance to you. Love to you all. Have a good night.